Okay, I chose question 25. A 55 kilogram ice skater is gliding along at 3.5 meters per second. 5 seconds later, her speed is dropped to 2.9 meters per second. What is the magnitude of the kinetic friction acting on her skates? So we already have been given some values here. We know that her mass is 55 kilograms. We know that her initial velocity is 3.5 meters per second. The time interval we're giving is 5 seconds. And then her speed drops to 2.9 meters per second, which would be considered our final velocity, if you will. So we have our givens. We know that t is 5 seconds. We know that our initial velocity is 3.5 meters per, 3.5 meters per second. We know that our final velocity, if you will, is 2.9 meters per second. Now, with all this that we're given, the equation that comes to mind is acceleration equals our final velocity minus our initial velocity over time. Now, we need acceleration to be able to figure out the magnitude. So if we plug these numbers in, you're going to have acceleration equals 2.9 meters per second minus 3.5 meters per second over 5 seconds. And I already did this calculation in my calculator, but essentially what you end up getting is acceleration equals a negative 0.12 meters per second squared. Okay, so now that we have that, we're going to use the equation that we were given for Newton's second law, which is force equals mass times acceleration. Force is essentially, friction is a force, so that's essentially what we're solving for there. So that brings us back to our 55 kilograms for our mass. Our acceleration we just discovered is negative 0.12 meters per second squared. So what you'll do is you'll do our 55 kilograms times our acceleration of negative 0.12 meters per second squared. Plug that into your calculator, and the magnitude that you get is negative 6.6 newtons. However, with magnitude, we don't really, care for the negative. So it's 6.6 newtons. That is the kinetic friction acting on her skates.